Alright, hello everyone. So, yeah, basically the stream cut off last time, so I'm re-recording this part. This is the part where it got cut off, more or less. Perfect, it actually just cut off right after I finished the problem, so yeah. Gonna restart, and we're gonna start talking about the difference quotient. Um, yeah, so, difference quotient of f of x. The intuitive idea of what this is you think of a point x of f of x, x and f of x, so that's the x and y coordinate, right? And we think of another point that is h units away from it. So you can see that I have that kind of there. And then you take the slope between those 2 points. So those 2 points right there, x and x plus h, we're going to take their slopes. So rise over run, we got that right here. So that's the same as change in y divided by change in x. So yeah, let's just plug these things in and see what we get. So in the numerator, the y values are the f of x plus h and f of x, correct? So f of x plus h minus f of x divided by, be consistent, so do x plus h first instead of x. So don't switch them, otherwise you get negative slope. And then we can actually simplify this one step further, because as we see here, the x's, they actually subtract out, so let's get rid of them. Then we end up with f of x plus h minus f of x, all divided by just h. So this is what we call the difference quotient of f of x. It'll be used to pretty much just figure out what's a derivative and how do we work with it. Alright, so question that you can ask is, what happens if we let h approach 0? So if we take the limit as h approaches 0 of f of x plus h minus f of x divided by h, this gives us the rate of change of f of x exactly at x then. So in other words, this is what we call the derivative. So we also write it, just a quick thing, we write it these 3 ways pretty much. F prime and dy dx are the more common ones. Df dx you might see depending on the function. Like if your function is f, then you might have df dx, or like for g, dg dx, or like theta of t, you can have d theta dt, stuff like that. But yeah, so derivative is this. We can say f prime or dy dx equals this definition right here. Alright, so now that we have the definition of derivative, let's start working with derivative rules. So I'm just going to give you the basic derivative rules here. I'm not going to give you a derivatives table. I'm pretty sure you already have that memorized or something, but if you need to, I'm going to leave a thing in the description. So you'll have a link to a file that has derivative and integral tables. Alright, so here we have the 3 basic rules: power rule, product rule, quotient rule, chain rule. So you see boxes here. I'll explain those by first going over the chain rule. So got a function and a function like that. So when you take the derivative of that, actually, let me color code this. When you take the derivative of that, you get the derivative of the whole outside with the inside as is. So keep it exactly as is. Then multiply by the derivative of that inside on the outside of everything. I've seen this as a very common mistake where people will try to take the derivative of that inside, so make sure that you don't do that. Keep it outside. Don't do anything weird with it. Alright, so how does this come into play with all those boxes and everything else? So if we do this power rule thing, get ddx of box to the n power, right? Then we get the power coming down, and then box stays as is, and then n minus 1. Then I have us do ddx of box. So I would say to always get into the habit of doing that, no matter what it is. If box is x, then you get 1. If box is not x, then you get something else, like dy dx, dg dx, dt dx, d whatever dx. Alright, and then the product rule and the quotient rule, memorize it kind of like this. Product rule will be first times the derivative of the second plus second times the derivative of the first. You can also switch those, or derivative first times second plus derivative second times first. Doesn't matter, any of those combinations works. Just memorize it that way rather than F's and G's. Quotient rule, this is the one that's you definitely need to not memorize by just F's and G's. So quotient rule is bottom times the derivative of the top minus top times the derivative of the bottom, all divided by the bottom squared. I've seen things where they've been switched and stuff like that, and a lot of time when professors or AP writers or whoever does that, the point is to test whether you're paying attention and you actually understand the concept of the quotient rule rather than just you memorized it from a textbook. So remember it this way, and so that means if G and F, they get switched, so you get G over F instead of F over G, then you're able to do that pretty easily. And you won't necessarily mess up by doing G F prime minus F G prime divided by G squared. So like G over F, you know that all those, they're going to switch, right? Yeah, so the point is, memorize it, bottom times derivative of top minus top times derivative of bottom divided by the bottom squared, or however you need to memorize it, without just the symbols. I just suggest something with top and bottom, or numerator and denominator. But when I talk fast, accent happens, so that's why I say top and bottom. Okay, so let's go through some examples. So because this was cut off yesterday, that means I've gone through this already. And so for number 2 over here, we're not going to do it in the video just to save time. I'll have you just do that on your own. And so yeah, let me just erase it right here. And as I erase it, I'll explain. So I'll have some solutions in the description below. If you're watching this on Monday or Tuesday, December 11th or 12th, then most likely they'll already be up. If you're watching before that, then probably not going to be up because time. So that's one of those things I'll leave a solution to somewhere in the description, probably just a link somewhere. So quotient, chain rule, that's going to happen when we take the derivative. So dy dx equals, okay, so let's see, bottom times the derivative of the top, which is negative sine x, minus top times the derivative of the bottom, all divided by the bottom squared. So I just squared it quickly there because that's an easy thing to square, right? Alright, now let's do the other thing. Derivative of ln is 1 over whatever's inside. Then we got to chain rule that. That's a double chain rule because you got x squared inside of e to the x. So derivative of e to anything is just going to be e to whatever that is. Then multiply by the derivative of that thing, which is 2x in this case. This is going to be fun. Okay, so let's see what we can do here. There seems to be a factor of x in all of those for the first term. So let's divide that all out, and then here you'll have an exponent of 3. So you will have negative x sine of x minus 2 cosine of x, all divided by x cubed, plus 2x e to the x squared, all divided by 1 plus e to the x squared. You technically could simplify this further. I am not going to because of time. But if you want to, sure, go ahead. I'm probably not going to leave it a description solution, so yeah. You can check on your own somehow if you want to. Okay, anyway, moving on to the last topic of this video, which is going to be implicit differentiation. Alright, so question is, when is implicit differentiation used? That's basically if you're differentiating something and it's to a different variable than what you're differentiating with respect to. So for instance, over here, we have x squared plus y squared equals 1, and we're taking d dx of that. Y is not x, so something interesting is going to happen there. It's probably just easiest for us to, well, start it. So let's just find dy dx here. That's the goal. All right, applying d dx, we get 2x times, I'm going to say dx dx, so that whole box thing, plus 2y, and then I'm going to do the d box dx thing there too, equals, then we get 0, because derivative of constant 0. Alright, so if we look at these, we see that dx dx, that's 1. And we want to find dy dx, so let's just start to isolate this thing. And oh, notice that dy dx just stays as is. Move 2x to the other side, get negative 2x there. And then if we want to get dy dx alone, all we need to do is divide out 2y, then we get negative x over y, and we have our derivative right there. Okay, so let's just do another quick example here, and I will end the video with that. Okay. So 2xy plus tangent of x squared equals 4e to the 2y. So 2 times ddx of xy, you're going to product rule that. Actually, no, let's just keep this here. Just, it'll be helpful to kind of visualize exactly what's going on here. All right, times plus ddx of tangent of x squared equals, make sure you have those parentheses and you know that that's not tangent times x squared. All right, and then actually let's put the 4 in front of ddx of e to the 2y. All right, now let's take these derivatives. First times the derivative of the second, plus second times the derivative of the first, that's just 1. I don't need the ddx x again, so just, there you go. Plus, derivative of tangent is secant squared. Inside stays the same. Derivative outside of inside is 2x. Multiply that outside, like I did. 4 times e to the 2y, and then got to chain rule that. You got a, let's see, you got a 2 dy dx then. Okay, so now let's clean this thing up. So that 2 can distribute in, and then we can kind of start cleaning it here. And then just keep simplifying those things out. Okay, so now we see that we have dy dx on both sides, right? So what we can do here then is just separate them. So the non-dy dx's and the dy dx's, put them on separate sides so that you can factor out dy dx. Okay, so doing that, we get 2x dy dx equals minus 8e to the 2y dy dx equals negative 2y minus 2x secant squared of x squared. All right, let's see. So we can also factor out a 2 dy dx actually from the left, so let's do that. Make things a little bit simpler. Then we get x minus 4e to the 2y inside equals negative, actually no, factor out negative 2 is going to be useless, so let's just factor out 2. Negative y minus x secant squared of x squared. So divide out everything except for the dy dx from both sides, and then we will get dy dx equals negative y. So, oh, the 2's first. So notice you can do that. Negative y minus x secant squared x squared, all divided by x minus 4e to the 2y. So that hot mess is your final solution for dy dx. Alright, done with this video. We're going to do some more stuff next time. Yeah, so stay tuned for that, and see you in the next video.